Hello and welcome to GIS. Today in this video you will learn a brief introduction to GIS and also you will learn how to build a topology in ArcGIS. The term topology in the context of GIS essentially means spatial relationship between features. So topology is the mechanism used in GIS to manage how the features are related to each other. It's actually a branch of mathematics. It's a part of geometry. So the geometric properties and its relationship that are unaffected by the continuous change of shape or size of the features is one of the definition of topology. In the context of GIS, when you hear the term topology, you should think how the features relate to each other. Basically, topology is a set of rules in which how points, lines and polygons share their geometry. Topology checks and validates the spatial relationship of neighboring and overlapping features. Historically, topology was a part of actual data structure, and what it means is that it was a part of actual data format. Topology was actually stored in tables. A big thing about topology back then was that it was based on shared geometry model so that the old way of doing things and looking at how it was actually stored in the tables. Today the geodatabase stores topology as features, behavior and rules. It's a different kind of approach for modeling geography that uses different sets of rules and it uses the computer's ability to calculate the coincidence vertices and features to determine the spatial relationship in the memory of computer without explicitly storing all that information in a table. So that's how it's done these days. It's more flexible, it's more powerful. It allows the topology to be determined by the user rather than the data structure, and it's really functional of how computers have changed over time. When the ArcInfo coverage was predominant data format, computers did not have large amount of RAM, that is random access memory, and processors were not as fast as they are today. They had relatively small hard drives, so things were not done in the memory of computers. Back then you would commonly go and read it from a table on your hard drive or read it from disk. After that, whatever information that you get from the table, just extract the information that you need. Today the computers are very different. They are very powerful with more powerful processors or multiple core processors. Many computers have many gigabytes of RAM now, so things can happen in the memory of computer. That's how things more commonly happen in today's computer world technologies. In topology, there are lots of errors. So some of the common examples of errors are here. First example, we have precision and accuracy. Precision identifies the closeness of two or more measurements to each other. Accuracy refers to the closeness of the measured value. Example of the diagram is been given here, as you can see. Second example, that is silvers. Silvers are small, precious gap often formed while we are digitizing features in GIS. So here you can see these are the two polygons which is created. In between there is a silver. This is basically a small gap between the two polygons. The third example is overlap. Overlap are most commonly seen in polygons or lines that are on the top of each other, which results in double counting area. So here in this diagram you can see these are the two polygons in which it forms an overlap here. And there are dangles, overshoot, undershoot, which are the common examples of line errors. Why in this world do we need topology? We need topology for a couple of big reasons. It provides the basic spatial analysis. So with GIS, we often want to know what features is next to another feature or what road connects to a different road. Topology helps us to determine the simple things of spatial analysis like area or length calculation of feature, as well as doing things like select by location in the software. Say, select all the bird nests that are in the particular type of forest. So these are the simple type of spatial analysis that are made possible through topological behavior in the data and in the software. And then of course there are more complex type of analysis that are made possible by topology. Things like tracing flow through utility network or routing bus through transportation network. This requires connectivity of arc through nodes. If the connectivity is not built in and there is not a system of topology to help to keep with how the features are connected, you cannot route a bus through a network of lines and arcs. So topology is required for spatial analysis. It's also very powerful for ensuring the features are spatially correct, or sometimes you will see that it's used to ensure the integrity of data. So topology allows you while we are editing to ensure that polygons do not overlap or there is no gap between persons, or maybe bus road follow a road or coincident with the road, or maybe road connect at the intersection. Topology allows us to spatially analyze our data as well as ensure the integrity of our data in being spatially correct. So now we'll learn how to build a topology. For that, first of all, open ArcMap and then open ArcCatalog by clicking on it. In this, browse to the location where the file has been saved. So these are the two shapefiles you will be adding. Now we'll be building topology in ArcGIS. So for that, open ArcMap. For doing topology, at least we need a line shapefile, that is the road shapefile or river shapefile, etc., as well as polygon shapefile, that is the region or huge building shapefile, etc. Also, you can add point shapefile, but here I'll be using line and polygon shapefiles. The first thing that you are going to do is create a personal geodatabase. So for that, in Catalog, right click on Topology folder. A flyout is displayed. From the flyout, select New. Another flyout pops out. From that flyout, choose Personal Geodatabase. Just right click on New Personal Geodatabase. A flyout is displayed. From the flyout, choose Rename option. And then rename it as Topology. And press enter. So the name has been changed. Within that, we'll create feature data set. And it's important to have a feature data set in order to be able to create topology inside it. The main reason really, I think, that it enforces the idea that you have to have the same coordinate system for all the feature classes inside the feature data set, which is the requirement for building topology. So it's really easy to do it. In Catalog, right-click on Personal Geodatabase, a flyout pops out. From that flyout, select New. Another flyout pops out. From that flyout, select Feature Dataset. The new Feature Dataset dialog box is displayed. In the name text box, type Land Use and then click Next. Here I have to specify the coordinate system. So expand Geographic Coordinate System. Then go down and expand World. In World, select WGS 1984 and then click Next. Now here, if you want to specify the vertical coordinate system, you can do it, but it's not compulsory. So I'll not specify any vertical coordinate system. After that, click on Next again. Here, keep XY tolerance, Z tolerance and M tolerance as default. And then at last click on Finish button. The dialog box is closed and the feature dataset has been created. As you can see, land use has been added here. The next thing that I am going to do is import the shapefile, that is the building and the road shapefile, into the feature dataset. So for that, right click on feature dataset. A flyout is displayed. From the flyout, select import. Another flyout pops out as you have more than one shapefile. So select feature class multiples. Feature class to geodatabase multiple dialog box is displayed. Click on the folder icon next to input feature text box. The input feature dialog box is displayed. In this dialog box, select both the shapefile together and then click on add. The input feature dialog box is closed and the input feature with the location is specified in the input feature area. Next, keep the output geodatabase as it is and then click on OK button. The feature class to geodatabase multiple dialog box is closed and it will take a little while to import feature class, that is the shapefile, to the feature dataset. So the feature class has been imported to feature dataset. As you can see, the building and the road shapefile has been added in the data view area as well as in the table of content. After that, I'll be creating topology. So for that, right click on feature dataset. A flyout is displayed. From the flyout, select new. Another flyout pops out. From that flyout, select topology. The new topology wizard is displayed that explains how this all works. So we are going to create one. Click next. After that, in the enter name for your topology text box, keep it as default. In this case, it's going to use the same name based on the feature dataset, so that's fine. And you are going with the default cluster tolerance as a rule. Click next again. Now here you have to select the feature class that will be involved in it. The great thing about topology in geodatabase is that you can have topological rules that includes more than one feature classes. So select the building and the road shapefile checkboxes and then again click next. Now here in the enter number for rank, keep it as default and click next. Here we have to specify the rules for the topology. So click on add rule button. The add rule wizard is displayed. In this wizard, click on the down arrow in features of feature class. A list appears. From that list, select road, that is the line shapefile. Now we need to specify the rules for the road. In the rules, click on the down arrow. A list of rules appears. From that list, select must not have tangles. In this case, while digitizing road, river or line, we have made some mistakes while digitizing. For example, while digitizing something, we leave these two lines a bit short and both lines are not been connected. And there is another case called as overshoot. A line crosses another line, but actually it must join together. And then ensure that show error checkbox is selected and choose OK button. The add rule wizard is closed and the rule has been added here, as you can see. Similarly, we'll add 2 to 3 more rules. So for that, again click on add rule button. The add rule wizard is displayed. Now we'll be specifying rules for building. So click on this down arrow and select building. And then in the rule, I'll go with the default rule, that is must not overlap. Also ensure that show error checkbox is selected and then choose OK button. So here you can see the second rule also has been added. Now again click on add rule button. The add rule wizard is displayed. In this wizard, ensure that building is selected in features of feature class. And then in the rules, click on the down arrow. A list of rules is displayed. So from here, select must not have gaps and ensure that show error checkbox is selected and then choose OK button. So the third rule also has been added. So similarly, we can add as many as rule as you want. For now, I'll go with these 3 rules and then click next. This gives the summary of the topology and then click on finished button. The wizard is closed and a warning box opens up which asks if you would like to validate it. So I'll say yes. Note that in feature dataset under land use we have a new list here which is the land use topology. So it's different thing, different object in ArcMap. Now we'll add the feature class if not added, and also add the topology to the data view area and as well as to the table of content. So if you want to add all these three, just drag this feature dataset to the data view area. But in this case, the polygon and the line shapefile has been added. So just drag the land use topology to the data view area. Once you do that, a warning box will be displayed which asks us that if you want to add all the feature class that participates in land use topology to the map. So just click yes, and you can see the lots of error has been displayed. The red mark are the error ones. Now I am going to show how to correct this error in ArcGIS. So for that you need to have topology toolbar. Just click on the gray area where no toolbar is activated. A list appears. In this list, go down and select topology. So here we have the topology toolbar. Just drag it to the top and adjust it there. After that, go to editor toolbar and click on editor. A list appears. From that list, select start editing. So automatically all the tools in the topology toolbar is activated. Next, click on the error inspector in the topology toolbar. The error inspector window is displayed. It basically shows how much error has been there. Just minimize it right now, and I'm going to show some of the things. So you can see here we have an error, but for me it's not an error because this is an end of the line. Also similarly in this polygon we do not have any error because it's a single polygon. So I need to clear all this. So just drag the error inspector at the top. Now in the error inspector, click on the down arrow in the show area. A list appears. From that list, select any rule that you want to add and then click on search now button. So here you can see all the errors has been displayed. Just click on the first error. The error is getting highlighted. So just zoom into it. And here you can see it's the end of the line, so you do not have any error. So in order to remove this error, just right click on it. A flyout is displayed. In this flyout, choose mark as exceptions. Now the first error has got removed and the second error has got highlighted. So just zoom into it, and here you can see the two lines which needs to be connected. And then select the line and click on Create Feature in the Editor toolbar. The Create Feature pane is displayed. In this pane, select Road, and in the Construction Tools, select Line and create a line here which will join both the lines. Just double click on it. A line has been created. Now in order to select these three lines, just select these three lines by pressing Shift and then again go to the editor toolbar and click on editor. A list appears. From that list, select merge. The merge dialog box is displayed. In this, if you do not have any attribute added to the line features, select any one road and click on OK. So here you can see the line has got merged. Now remove this create feature and activate the land use topology. So the second error has also been corrected. Now the third error has got highlighted. So it's similar to the first error. Just right click on it and click on mark as exceptions. The third error has also been removed. Here also we have the similar case. Just click on the error. A flyout is displayed. Click on mark as exceptions. Now here we have some more errors. The errors are getting highlighted with black color so you can identify it. Just zoom into it and here you can see this line is not joined. So for that, close this land use topology. Now in order to correct this, just double click on the line and here you can see the editor toolbar has been activated. So just click on add vertex and add one more vertex here and just drag the previous vertex to that line. select both the line by pressing Shift and then go to Editor toolbar and click on Editor. A flyout is displayed. From the flyout, select Merge. The Merge dialog box is displayed. In this dialog box, select any one road and then choose OK. So here the line has got merged. Now again go to Table of Content and activate the land use topology. Now in order to remove this error, just right click on the error in the error inspector. A flyout is displayed. From this flyout, select Mark as Exceptions. Now this error has got highlighted. So zoom into the error and here you can see the line has got extended too much. So in order to trim this line, select the line, go to Error Inspector and right click on the error. A flyout is displayed. From the flyout, select Trim Options. The maximum distance for the trim has been displayed. So here it's asking us to specify a distance. Let me specify 0.5 and then press Enter. So the line has got trimmed and the error also has got removed. Now here we have the last error for the line. So in order to remove this error, just right click on the line. A flyout is displayed. From this flyout, select Mark as Exceptions. Now here you can see all the errors of must not have dangles got corrected. Now in order to remove all the other errors, just go to the show area at the error inspector and click on it. A list appears. From that list, select the second error that you want to correct and then click on Search Now option. So the error has been displayed here in the error inspector. Just click on the error. The error is highlighted. Just zoom into it. Now in order to remove this error, just right click on it. A flyout is displayed. From this flyout, you can choose Merge or Subtract. If you select Merge, both the polygon will get merged, and if you select Subtract, then this area will cut off from both the polygon. So let me show first with the Subtract. Just click on Subtract. So here you can see the polygon has got cut out. Basically it was the common area which was shared by both this building. So this area has got cut out. Now here we have highlighted with black color. Just right click on it. A flyout is displayed. From this flyout, select Merge option. The Merge dialog box is displayed. So here in this dialog box, if you haven't add any attribute to the building, so just select any one building and then click on OK button. Now again, third error has got activated. So in order to remove this portion, just double click on the polygon. The Edit Vertex toolbar is displayed. From this toolbar, select Delete Vertex and then click on the vertex which you want to delete. So the vertex has got deleted. Now adjust this vertex to here. So the error has got corrected. Now in order to remove this, just right click on it. A flyout is displayed. From this flyout, select Mark as Exceptions. So all the errors of must not overlap has been removed. If you want to ensure that must not overlap error has got removed or not, just click on Search Now. And here you can see all the errors has got removed. So there is no any error displayed here in the error inspector. So this is simple and useful tool. For example, there are lots of error available, but it's going to show you the amount of error which is just visible in your display. Now go to Error Inspector window and in the show area, click on the down arrow. A list appears. From that list, select Must Not Have Gaps and then click on Search Now. So all the errors has got displayed here in the Error Inspector. Now in order to correct this error, just click on the first rule type. The error will get highlighted. For me, this is not an error because it's a single building. So just right click on it and select Mark as Exceptions. Now here you can see the third error has also been highlighted. So in order to remove this error, go to Error Inspector and right click on the error. A flyout is displayed from the flyout. Choose Mark as exceptions. As this is the only single building, it's not connected with any other building. So just right click on the error in the error inspector. A flyout is displayed from the flyout. Select Mark as exceptions. Similarly here, we'll right click on the error and select Mark as exceptions. Here also. Now here in this error you can see the edge of the building has got highlighted. As it is not connected with any other building, so this is the end of the building. So for me it's not an error. So in order to remove this, just right click on it. A flyout is displayed. From the flyout, select Mark as exceptions. And here you have got another error activated. Just zoom into it and you can see the gap has been created. So in order to remove this gap, just double click on the polygon. In this toolbar, select delete vertex and then delete this vertex. Now here the gap has got removed. Now similarly, in order to remove this gap, click on modify sketch vertex and just double click on this vertex and drag it to the corner. So here it is. Now in order to remove this error, just right click on the error and then select Mark as exceptions. Another error has got highlighted. So here just zoom into it and you can see this is the edge of this building. Just right click on the error and click on Mark as exceptions. As this building is not connected with any building, so this will not count as error. Now here you can see this building is a single building which is not connected with any other building. Just right click on that and select Mark as exceptions. Just right click on the error and then select Mark as exceptions. I've corrected all the errors. There is no any error left. So if I go to error inspector window and search for topological error by clicking on the down arrow and select any one type of error and then select search now. Here you can see there is no any error. Now I have topologically corrected the database based on the rules that I have specified. Click on cross in error inspector and then go to editor toolbar and click on editor. A list appears. From that list, select stop editing. So that's how we correct all these topological errors. That's all. I hope you liked the video. Stay tuned.